Welcome and thank you for standing by. All lines have been placed in listen-only mode until the question-and-answer session of today's call. Today's call is also being recorded. If anyone disagrees, you may disconnect at this time. We will turn the call over to the host shortly. Thank you.
Good afternoon, everyone. I'm Leah Cheshire, and thank you for joining us for today's Starliner spacecraft update telecon as part of NASA's Commercial Crew Program. Starliner will launch NASA astronauts Sunita Williams and Butch Wilmore on its crewed flight test to the International Space Station ahead of future operational crewed missions. To discuss the spacecraft and planning today with us, we have Steve Stitch, Manager of NASA's Commercial Crew Program, Mark Nappy, Vice President and Program Manager for CST-100 Starliner at Boeing, and Joel Montalbano, Manager of NASA's International Space Station Program. As always, if you're joining us on the line and you have a question, please press star 1 to raise your hand and star 2 to lower it if your question has been answered, and we'll get to that portion later in the call. First, we'll start out with some opening remarks, and I'll turn it over to Steve.
Yes, thanks, Leah, and thanks for all the interest today and for all those who are joining the telecon today. It's a pleasure to be here representing the Commercial Crew Program and giving you an update on where we are relative to Starliner's first flight on the crewed flight test. I will tell you that the team has made a tremendous amount of progress since we last spoke back in early June. We've learned a lot about the various issues with the P213 tape and also the soft links on the parachutes. And I'm extremely proud of the entire NASA and Boeing team and also the suppliers that have rolled up their sleeves and dug in and made a tremendous amount of progress. I would say, first of all, on the parachutes where we had the soft link issue that we talked about last time, this particular area that didn't have the safety factor of 2.0 required for a safety critical system, that has been redesigned by the team. They're in the middle of testing of that design. They had a very productive technical interchange meeting in early July at the supplier, and not only did they redesign that particular joint, but also went through and looked at all the rest of the areas on the main canopies and the drogues and the forward heat shield parachutes and the pilot chutes, and didn't really find any other areas where we had a joint that was had improperly designed. So they went through and did a thorough review of the entire parachute system to make sure we didn't have any other areas that we would have a concern about. So that was very productive and a great technical interchange meeting. On the P213 tape, this is a tape that's widely used across the aerospace industry for many applications for protecting wires from abrasion. I would say in the NASA database, the entries in the database were a bit inconsistent relative to the flammability of that tape at various levels of oxygen concentration, and so it was a bit confusing as to when it could be used and when it couldn't. The Boeing and NASA team have worked very hard on the P213 tape, and Mark will talk more about that, but the team has actually removed a substantial amount of tape. They've broken the spacecraft into two areas, what's called the upper dome in the crew module and the lower dome beneath the floor, and they've remediated about 85% of the tape in the upper dome and have removed a substantial number of pounds of the tape actually from the vehicle, and also developed a few techniques to mitigate propagation should anything happen, and an additional tape to apply. So that has been an extremely valuable exercise and tremendously productive by the teams that have been working hard on that ever since we last talked. We've also continued to work on progress toward the crewed flight test. We are 98% complete with all the certification products for that flight, and so we've continued to bring items to the program control board and sign off on the various certification products, which has been really good. We did conduct a forward heat shield parachute overqueue test at the highest dynamic pressure that those parachutes should ever see. We did that in early June. That test was a successful test, and we have no concerns on the forward heat shield parachutes. And so that was a big activity that we were working on when we last talked, and that was completed successfully in the summer time frame. We continue to work on the software and have worked through many items in the software testing and with the crew, and that's largely behind us. So we've made a lot of progress in those areas as well. Also, as the Aerospace Safety Advisory Panel has discussed, they recommended that we have an independent team to go off and look at the issues relative to the final resolution to go work toward flight for CFT. NASA and Boeing have put in place several different layers of independent reviews to work through the issues and to make sure that we didn't have anything else out there. I'll start with Mark's team. Mark has an independent team within the company that's looking through various areas that we've closed out for flight, and they've been reviewing that, and they'll continue to do so as we move toward flight. On the NASA side, we ask our chief engineer to go off and re-interview and re-talk to every subsystem manager. The vehicle is divided into subsystems, for example, propulsion or thermal protection or parachutes. Go interview all those subsystem managers and make sure that there's nothing else out there that we should be concerned about, and if there is, we'll elevate that and we'll go do deep dives and work those. And then finally, within NASA, we have asked the chief engineer for the agency, his deputy, and the head of the NESC to work with our technical experts and to independently review each of the major issues remaining for flight. And of course, they have an independent reporting path for the flight readiness review that will be held before the CFT flight. We did brief this plan to the Aerospace Safety Advisory Panel last week, and they were pleased with our plan of independent reviews, and they felt like this was exactly what we wanted to do on the NASA side, the Boeing side, and then as also pointed out by the Aerospace Safety Advisory Panel. So I'm super proud of the team. Overall, we're making a tremendous amount of progress toward flight. We will go fly this mission when we're ready. It's hugely important for commercial crew to bring on a second crew transportation system for the ISS program, and I know Joel will talk more about that. And with that, I'll turn it over to Mark Nappy from Boeing.
All right, thanks, Steve. And good afternoon, everybody, and thanks for joining us. Last time we talked, we let you know that we were standing down for two main items. Steve talked about them, the parachute soft link issue and the tape flammability issue. Just a reminder, the tape that we used, Steve talked about a little bit of ambiguity in the specification, and we considered the application that we had as acceptable later in the design process and the certification process. it was determined that tape was flammable in some of the applications that we had. So we needed to go back and revisit that. On the parachutes, we have a soft link that is the link between the main lines that come up off the capsule and then turn into the risers, where that soft link was found to have been tested incorrectly many, many years ago. And when we did test it correctly, it reduced our factor of safety, which gave us less margin than we would like from the factor of safety of 2.0. So a lot of work's been done. Both those topics are very well understood at this time, and I'll talk a little bit about what we know and what our path forward is to closure. A very impressive effort by the teams. Both sets of teams jumped on these issues very quickly and got to resolution. On the tape, we formed a joint Tiger team between us and NASA, and their job was to test and recommend remediation efforts to the production team so that we could get to work on the vehicle and clean the situation up. They took just a couple of weeks, got a lot of testing behind us that did a couple things. Number one, it told us what kind of remediation efforts we could use, and it also told us where we had applied tape and its application was okay, and we didn't need to do anything. So that effort is still ongoing, but we are working on the vehicle, and like Steve mentioned, the upper zones are complete, and the lower domes are just getting started, and those zones will be addressed over the next couple of weeks. The chute team was a joint effort between us, NASA, and Airborne, our supplier, and options for the soft links were discovered right away. It was actually a really interesting story. One of our engineers on the program builds chutes for personal use, and the day that we found out that the testing was suspect, he went home in his garage and built 3 prototypes to try and understand what we could do next, and brought those back over the weekend. We tested them, found some load instruments here at KSC and tested them, and right off the bat, we had a really good head start on figuring out what we needed to do to redesign those. So we worked those into the plan with our supplier, and really that helped contribute to the final design that's currently in work. We had a couple of technical interchange meetings with all 3 parties, and the teams have made some good decisions, and we're off implementing them now. And to talk a little bit about the details of what we're doing on the chutes, the soft link design has been modified to a stronger Kevlar wrap, and it's currently in fabrication. We made a decision to go to the next configuration parachute that was planned for PCM1. We call those our 511 chutes, as a slight improvement of additional stitching on those to a radial joint, and we considered that a really good move at this point. The soft link will be incorporated into that chute, and that chute was planned to have a drop test this fall, and so we just kind of piggybacked on that drop test, and we'll just basically kill 2 birds with 1 stone here and go straight to that chute. That new parachute is the critical path, the delivery of that parachute. It's being built by Airborne as we speak, and the soft link is being incorporated into that. And we're anticipating that there's 3 chutes, and the final chute will be delivered around the beginning of December. We expect that the drop test will occur in mid to late November. That's what the planning indicates at this point, and we'll watch that closely. But again, the parachute delivery is the critical path. On tape, the team has been focused on the remediation techniques, like I talked earlier, and what kind of applications of this tape are susceptible to propagation of flammability. And so we're applying all those remediation efforts. The vehicle's been broken up into 12 zones, as Steve said, and we're addressing each zone primarily with tape replacement. If it's easy to take it off, or if it's easy to get to, we certainly are taking it off, and we've taken off more than we expected. It comes off rather easily. And we'll continue down that path, and for some of the areas that are maybe a little more difficult to take off, we'll look at other remediation techniques such as barriers or protective coatings. We'll expect to have all those zones addressed and the vehicle into some level of regression testing by the end of September. As far as the flight readiness and launch readiness, the chutes, like I said, will drive the readiness for potential launch dates. And right now, based on the current plans, we're anticipating that we're going to be ready with the spacecraft in early March. That does not mean that we have a launch date in early March. That means that we are ready with the spacecraft then. We're now working with NASA Commercial Crew Program, ISS, and ULA on potential launch dates based on our readiness. It's complicated manifest on ISS, as you all know, and the launch pad of ULA, so we'll work that throughout the next several weeks and see where we can get fit in, and then we'll set a launch date. Of course, we have other areas that we're working in parallel with all this. We continue to train with the crew. Butch and Sonny have been fully engaged in all our simulation training. We're working off some backlog, closing the few remaining engineering products for flight. And in some cases, we're pulling some work in that we had planned for later, but since we've got the time, we're going to get it out of the way now. And of course, PCM1 is also being worked, and we're trying to hold those current plans with all of our engineering products and our hardware, software, et cetera, so that we can maintain the plan after CFT. Team's done a remarkable job at, number one, addressing all these issues and getting work done and coming up with good ideas of things that we can go do to make the best use of this time. Very proud of their efforts. So that's all I have this afternoon for you. And we'll be looking forward to the questions, and I'll turn it over to Joel.
Hey, thank you, Steve, and thank you, Mark, and thank you, everyone, for joining us today. Steve and Mark gave you a really good overview of the Boeing Starliner and where we're headed. I'll tell you from an ISS standpoint, the Starliner vehicle remains a high priority to the space station program. And as Mark said, when the Boeing team, the Commercial Crew Program, ULA are ready, it's my job to go find a slot on ISS, and that's the plan. And so having a second crew provider is very important to the agency and to our programs, and that's something that we are working hard to make sure that we achieve. From an ISS standpoint, it continues to be busy, as Mark said, last Tuesday evening, we saw an awesome launch of NG-19 from Wallops Island. That vehicle delivered over 8,200 pounds of science research, crew supplies, and hardware, and it was captured and berthed to the ISS early Friday morning Central Time. And so the crew is already taking the supplies from that vehicle and using that to work on board the International Space Station. This Wednesday, we have a Russian spacewalk, and all the planning and scheduling is ready to go. We had a review today, and the teams are ready, and so we're looking forward to supporting the Russian spacewalk this Wednesday. Looking ahead, we have a Progress launch scheduled for the evening Central Time of August 22nd. And then, as you've heard last week, we're looking for the Crew 7 launch on the 25th, early in the morning, 2:49 Central Time. That sets us up for a docking a little less than 24 hours after launch. We also are planning the Soyuz in mid-September, Soyuz launch, where we'll have 2 Russians and an American on that vehicle. And then we're also working the late September Soyuz landing. And so from an ISS standpoint, the team continues to work the research and utilization as well as the visiting vehicles coming and going. And with that, I'll hand you back over to Leah.
Thank you all for those opening remarks. We'll now move into our question and answer portion of our call today. Again, please press *1 to raise your hand to ask a question and *2 to lower it if your question has been addressed. Please state your name, affiliation, limit yourself to 1 question and to whom your question is addressed. We'll start with Bill Harwood. Hi,
Hi,
Bill, are you
can you
there?
hear me? Hello, can you hear me?
We can hear you now.
Oh, thanks. Sorry about that. I guess this is for Mark and Steve both. Can you remind us of the long-range plans for Starliner with ISS, given the end of the program's coming up in 2030 or thereabouts? In other words, how many of these capsules are you going to end up actually flying? And really, I guess what I'm asking is there some kind of a drop-dead date for Starliner where if you don't get it going in time, you know, there's not any point in continuing or not much. Just given the time and money involved. I know it's a convoluted question, but I'm just curious if you have any thoughts you could share on that. Thanks.
Yeah, I'll start off and then I'll let Mark add any of his comments. I mean, our plan all along has been to have two different unique and diverse space transportation systems. We're working hard to get that in place. Once we do that, get Boeing through the crewed flight test and then the certification work for the vehicle, the plan would be to fly one Boeing flight and then one SpaceX flight for our crew rotations per year. And then if you just kind of look at taking us through the end of ISS, I mean, we've got plenty of flights for Boeing to go fly, and we're in good shape. And I know Mark and his team are working on each of those missions. He talked about the post-certification mission 1, known as Starliner 1, and they're working as well on Starliner 2 and 3 and 4 as well. So we'll see if Mark has anything to add.
Yeah, there's really no reason to change our plans. We've bought hardware for the 6 flights plus CFT. Still fits it well in the window that we have. There's additional flights are available outside of those 6 with other customers. So I think we are still committed, like we have been in the past, and we'll continue on.
Okay, thank you. Our next question is from Marcia Dunn.
Yes, hi. This question is for Mark. I'd like to hear more about the tape. You said some of the tape can stay, but how many hundreds of feet or whatever measurement, how much feet needs to be removed, and how much have you already removed from the spacecraft? And I'm just wondering if you could explain the process. Does somebody just get in there and just sort of peel it away like I would do on a piece of paper? Could you explain that, please? Thanks.
Okay. Good question. We split the vehicle up into 12 zones. There's an upper zone, which is basically the top of the spacecraft, and the lower zone, or lower set of zones, we call the lower dome. And we're targeting each one of the zones with what's the criteria for the tape that has and how it's applied in those areas. So first step is if we think that it needs to come off because it can propagate, then that's the first step, is try to take it off. And what we found is that most of our wiring is wrapped with, it has Teflon insulation. So just like your Teflon pans at home, stuff comes off them real easy. So when we started to attempt to take the tape off, it came off relatively easy. So on that upper dome area, we removed upwards of 80% of the tape. It came off very easily, and we just wrapped it with new tape. So we're in good shape there. I can't quantify it. I don't know how many feet of wiring we have, but you can imagine there's quite a bit of wiring in the capsule, and we did apply tape to protect the wire harnesses and quite a few areas from chafing and collateral damage, that kind of thing. So we get down to the lower dome, and we'll do the same type of approach. And if there comes an area where the tape is going to be difficult to remove and we could possibly cause damage, then we'll look at another remediation technique. The team has been testing. They found that there are protective barriers that we can put in between the wire harnesses. They found protective coatings. We could wrap with acceptable tape in absence of taking the tape off. And of course, there's areas we can just leave alone, because through testing we found that that the flammability does not propagate in some cases. So we'll apply, based on the area, we'll apply the right remediation technique.
Our next question is from Jeff Faust.
Hey, good afternoon. A question to follow up on Bill Harwood's question. In terms of the near-term manifest, this is a question probably for Steve Stitch. If Starliner flies as soon as next March on the crew flight test, do you think it would be possible to do the first post-certification mission in the second half of next year, or would you wait until 2025 to fly that mission?
Yeah, that's a good question. I think we need to look at exactly where we fly the crewed flight test first, and Joel and I and Mark and the Boeing team will have to work on where we put that crewed flight test, and then kind of look forward and see, where does that Starliner 1 flight fit? Could we fit it into the end of next year? We've been flying these rotations in 2 different slots, kind of a February slot and an August slot, and we'll have to look and see. It's probably a little too early to tell whether we could fit that flight in or not. We would like to fly it as soon as we can, and we also have to work, since Mark and the Boeing team have moved out on what we call the Dash 511 parachutes. I suspect that when that flight flies, from a hardware availability perspective, might be driven by parachutes. We'll have to go work through that whole schedule and see how it looks, but it's a little too early to tell.
Our next question is from Eric Berger.
Hi, thanks very much for doing this. I guess a question for Steve. Looking back at the parachute issue, when SpaceX switched from Mark II to Mark III, obviously that was a pretty big change, but they had to repeat their entire series of parachute tests back in 2019. And I think there was about 24 tests. And is Boeing doing just the one drop test this November, as Mark mentioned, or is there more? And can you discuss why there's just a single test of the soft link issue? Thank you.
Yeah. Thanks for the question, Eric. When we redesigned the parachute system for SpaceX, it was a significant redesign of that system because we learned that we have a phenomenon we call asymmetry, where one part of the parachute pressurizes more than the others and caused higher loadings on part of the canopy and the suspension lines. So when we did that, moving from the Mark II to the Mark III, we required more drop tests, and there was a number of development tests and a number of tests for certification for flight. What we're talking about here is really upgrading what I would call as a loop that transfers the load. This thing called a soft link. It's a Kevlar loop. It's a Kevlar piece of cord that is in 8 locations on each of the canopies, and then the other change on the Dash 511 chutes is a stronger joint where at the top of the canopy, around the canopy, where there's a suspension line, there's 80 of those that come down where that joint attaches. And so when we looked at the changes that we're talking about, we felt like we only needed one test to verify both the soft link and the new Dash 511 joint, given all the other tests and given how close both the soft link redesign and the joint redesign were to what we have already tested in all the previous parachute drop tests. So the design changes were, I would say, minimal, as opposed to what we had for Dragon, which was really a whole-scale change in the canopy.
Our next question is from Irene Klotz.
Thanks very much. My question's for Mark. I realize that throughout this whole program, Boeing has been very consistent on saying that the purpose of this is for NASA. But in light of what the company has been sinking in of its own costs at this point, could you talk a little bit about what the company's long-term plans for Starliner are?
So the our contract goes through PCM 6, and of course that carries us out to the end of the decade. And so, again, like I said earlier, very committed to fulfilling our obligations and continuing to develop the vehicle and flying those missions. I'm very excited about it. This is a pretty exciting business. Beyond that, that's new business. That's what we talk about as time goes on, as we learn more about the market, and it's all part of all companies' long-range business plans. We go through those each year and determine, how we're going to proceed. So, but as far as what we have on our existing horizon, again, we're one of two providers, and it's a great opportunity for us, and it's like Steve and Joel have said, they really need us to be there. So we're committed to providing that service.
Next up, we have Joey Roulette.
Thanks. Quick question for Steve. You had said that, I think, Steve, you said 98% complete with certification towards CFT. Is that does that include? Is that just the parachutes up the next 2% that you guys are looking at, or is there anything else that you're kind of looking to certify beyond that? And then for Joel, unrelated to Starliner, I was wondering if the investigation into the Soyuz coolant leak is closed after it seems NASA determined that the cause was linked to an external force. And if it is closed, or regardless, what is that external force? Do you have any idea what that is? Thanks.
I'll start with what's remaining to be closed out for the crewed flight test certification. It really is in, I would say, the following areas. One, obviously parachutes. We'll have some updates to some of the certification products that has been delivered, and we'll work through that and work through closing those out. We have the final certification analysis and products for the abort system. So we have mandated a pretty stringent abort requirement that all the way from the launch pad all the way to reaching orbit, 95% of the cases have to pass in actually looking at 10-second slices in time. And so that's one area that we're very close to getting that approved. And then we have, a couple of areas in the structure that we still have to go work on and approve. But it's really down to those areas, plus there'll be, for the remaining P213 tape, there'll be something called a materials usage agreement, which is sort of an agreement that says between NASA and Boeing, we agree the flight rationale for each area of any tape that would remain. We'll look at the wiring, we'll look at the critical functions in that wiring, we'll look at the voltages and the powers required, and then what mitigations have been employed. And those are kind of the main areas that are remaining to get certified for flight. And then I'll hand it over to Joel for the second question.
Hey, thanks, Steve. As far as the Soyuz investigation, it is not closed. We still have a number of review boards to go through. In fact, tomorrow we are talking at the Space Station Control Board about the status of the investigation team. We'll also go through the agency flight readiness review process. We'll be briefing at a program level and then at an agency level. And then so until the final flight readiness review, that work will continue. And then at the final flight readiness review is when we'll have the final go. As far as the external force, at this time, again, both the U.S. specialists and the Russian specialists have concluded that it's some type of external force. Is it orbital debris? That would be the most logical, but it's really hard to identify exactly what happened on that. But the teams have gone through, and again, they've looked at manufacturing, they've looked at technicians, making sure there's not a new technician. They've looked at how the leak occurred and the mechanics of the leak, talking to the material specialists. We didn't see, when we saw the leak, it went from everything was good till you lost all the coolant. And so none of that is indicative of manufacturing or tooling or anything like that. And so right now, orbital debris would be the leading candidate of the cause.
All right, our next question comes from Arya Alamahodai.
Hi, thanks very much. My question is for Steve and Mark. Steve, you briefly talked about some of the independent review teams that will be looking at Starliner. Can you talk in a little bit more detail about those independent teams and the timeline for their reviews? Thanks very much.
I'll talk about what we're doing on the NASA side, and then I'll let Mark talk about the Boeing side. So what we've agreed to do on the NASA side is, again, the chief engineer already has done one round of interviews with each of the subsystem managers, again, across the vehicle, the prop system, the life support system, the thermal protection, parachutes, wiring, so forth, asking them the question, hey, given the late finds, is there anything else that you would be concerned about in your system that we should go deep dive? And so far, we really haven't turned up anything big, because I do think our certification process is very thorough, and it looks at things from different angles relative to certain certification products that are required, and then a hazard analysis which looks across the systems and shows that you have a control for any hazard. The second thing we're doing within NASA is we're going to have Joe Pellicciati, who's the chief engineer for the agency, his deputy John McManaman, and also Tim Wilson do a deep dive on the P213 tape, on the parachutes, and then any other things that we have uncovered through our reviews. They do this on a weekly basis with our chief engineers, who bring technical issues to them. And what I like about this process is that they have different backgrounds than we have. Joe Pellicciati has a bit of a robotic spacecraft background, and then Tim Wilson, the head of the NASA Engineering and Safety Center, has a lot of experience relative to rocket engines and rocket tests, and so they ask questions and come at things from a different angle. We also said on the NASA side we would do one last look at two major areas. One, the propulsion system on the crew module, just to make sure we haven't missed anything there, based on lessons that we've continued to learn as we fly Dragon, and then the service module prop system as well. So I feel like we've got a pretty thorough look at different areas with the right expertise. I also do feel like within NASA we have independent technical reporting. In other words, engineering reports up through a different organization than the Commercial Crew Program, as does Safety and Mission Assurance and the Flight Ops Directorate, where the crew resides. So I feel like we've got a good look across the systems, and then we'll see if we miss something else. We have a little bit of time to step back and do a bit of a deep dive, and I'll turn it over to Mark, and he can share what Boeing is planning.
All right, thanks, Steve. We took a similar but a little bit different approach inside the Boeing company with reviewing a lot of the decisions that we've made leading up to CFT. So we have the engineering products, which are made up of the variances and our software configuration, and for the verification products on the engineering side. And so what we did was we're looking at all of those products and looking for where we made decisions to make sure that we're confident in the decisions that we made. That was done with a panel of experts outside the program, above the program, to look at each one of the products and determine whether or not, in their view, the decisions were made correctly. We're also looking at our hazard reports in the same manner. And then we've also looked at work that we decided to not do for CFT, but do for later flights. And are those smart decisions, or those things that we should pull into CFT? And we're through a great deal of that review, and really it hasn't uncovered any unacceptable conditions a lot of good discussions about why the decisions were made and good support on those. The next step is a few targeted areas where we're going to bring in another level of engineering support to dig a little bit deeper in some of these targeted areas, to look down into some of the details of the testing that was done, the analysis that was performed, et cetera, to make sure that we're covered in those targeted areas. And we expect that to be done by the end of September into October timeframe. But again, so far, nothing substantial has been found, and I think it's another confidence builder that, you know, the problems that we did find were found as part of the process, and we have a good solid process. It just, in this case, we found things later than we wanted to.
Our next question is from Will Robinson-Smith with Spaceflight Now.
Yes, hi. Thanks for taking my question. Suppose it's for Steve Stitch. With the adjustment of the Crew 8 crew with the addition of Jeanette Epps coming over from Starliner 1, can you talk about what the crew for Starliner 1 looks like at this point, and if there are any additional changes to the makeup that are foreseen in the future? Thanks.
Yeah, we have named two of the crew members for Starliner 1. We have named the commander, which is Scott Tingle, and the pilot, which is Mike Fink. And, you know, we'll name an additional 2 mission specialists at a later time. And, you know, what we've been doing with our crew members is, in some cases, doing I would say joint training on both Starliner and Dragon, and in this case, you know, Jeanette Epps is now, we're excited to watch her fly on Crew 8, and she's been doing joint training for both for a while, and we just announced publicly the crew of Crew 8 last week. So.
Thank you. Next question is from Issam Ahmed.
Hi, this is a question perhaps for Steve. You mentioned that the specifications about the P213 tape were a little ambiguous and not very clear. I was wondering if that points to a wider issue in the industry, given that it seems to be, from what I can tell, used more widely in the industry. Could this potentially cause any other issues? And did SpaceX make use of such tape, or did they have a different solution altogether? Could you share that with us? Thank you.
Yeah, look, I'll take the first part first. Relative to the confusion, the database sort of lists different applications of the tape. For example, if you use it on a metallic, like a metallic aluminum structure, well, the database would tell you that you could use it up to a 30% concentration of oxygen, which is well above what would be in a typical spacecraft cabin environment. So it just wasn't very clear what the constraints were for the wiring, and so we'll go back and clean that up. We've actually shared that data across all the programs. I know Joel sent a letter over to all the international partner countries as well as the cargo vehicle providers for the space station program. So we've been sharing that data, and I think this is one of the things that I've been talking to our engineering community about. Perhaps there's a bit of a gap in how we share information for materials usage across our programs, and something we need to look at as we have more and more programs working on hardware development for exploration. Second question relative to SpaceX, they did have some tape that they were using before the first crewed flight, and we were able to remediate that. It was only in a couple areas under the floor, and we were able to take that tape off, and so they're not using the tape in the same application that Boeing is using.
Next question is from Max Hoppenstead with The Washington Post.
Hi, thank you. I had a question for Mark, I guess. You mentioned that the decision to move ahead with test flight would be all the way up to your CEO. So I was wondering what David Calhoun has said to these latest delays, and I guess what is the sentiment in Boeing, given these changes will also mean more costs before testing and flying. And then just to confirm, am I understanding correctly that the decision for the test flight in March has not been made finally, or has that decision to fly in March been made? Thank you.
Let's start with the last piece first. What I'm commenting to is our readiness with the spacecraft. And so we'll be ready at the beginning of March, and there's just work ahead of us to determine when that launch date is based on our readiness. So we'll figure that out as time goes on with NASA. As far as the test flight and the timing, et cetera, I think was your question. We're going to do the right thing with respect to the safety of the vehicle, and that is first and foremost in every discussion that we have. And when it comes out that the answer is to do B because that's the safest thing for the vehicle, that's what we do, and then we figure out what the outcome of that is, what are the ramifications of making that decision. And that has been the approach all along. Actually, frankly, has been my experience in human spaceflight since the day I started in 1985. It's the way we do business, and so it's not foreign to our management team inside of Boeing, and again, it's the way we do business in human spaceflight. So I think that's the approach that we took, and I would never second guess that.
And just to clarify and add on to what Mark said about vehicle readiness, and what I know everybody would like is what's the launch date, and what Mark said is the vehicle will be ready in the March timeframe, and then what we have to do, working with Joel, is we have to look at what else is in that timeframe relative to ISS. For example, March is typically the month where the Russians will swap out their Soyuz spacecraft and crews. They'll do a crew rotation just like we do with our crews as well, and so we've got to look at that, and then other cargo flights around that time frame, and then Mark and his team have to go work with ULA, and that's when we are able to pin down a specific launch date, when we go work through all those things. We have not done that step yet. We have not taken the vehicle readiness and then mapped it into when we could go find a date that works with ISS and works with ULA, and that's really the next steps. So, and we talked about, we had our previous telecon on June 1st, and so we'll come back in a couple of months and update you again on where we're at, and hopefully by that point in time we'll have narrowed down when the launch date is, and we can talk about that. And then I would echo everything that Mark said about safety and redesigning hardware for crew flight. I think you've seen that with both SpaceX and Boeing, that when something is not safe and not acceptable for flight, that they'll go off and make either a design change the hardware, change the software. If I look back at Boeing, we've had several valves that have been redesigned, many areas of the spacecraft that have required additional modifications just to get to a safe crewed flight. And to me, that shows Boeing's commitment to Starliner for both the commercial crew program and ISS, but beyond that, I've seen nothing but an unwavering commitment from Boeing to do the right things. And as Mark said, many of these decisions go all the way up to the CEO of Boeing, and he's very supportive of the program.
The next question comes from Ken Kramer with Space Up Close.
Hello, thank you for doing this and for taking my question. It's for NASA and Boeing. I'd like to follow up on the parachute tests. I'm just a little surprised you're only going to do one test. So I'd like to know, have you got an independent opinion on this test, whether the one is sufficient? And I'd like to know, do you have a backup plan in case more than one is needed? And how long will it take you to evaluate the results of this lone test to give you confidence you could move forward if it works out? Thank you.
Yeah, I'll start off, and then we'll let Mark add his comments as well. So The team came to the conclusion that we only needed one test based on how much of the parachute system has changed, how much the mass has changed, how much the overall volume has changed. What we look for in parachute drop test is things that really appreciably change the way it would deploy, the way it comes out of it. Each parachute is packed in a bag. That bag is kind of pulled out of the parachute compartment, and then the parachute itself comes out of that bag and begins to inflate in various stages. And then these particular parachutes have what's called 2 reefing stages. In other words, the parachute can't go from out of the bag to full open because it would be overloaded. And so what the team looks for is things that would change that whole deployment sequence, that dynamics, the way that they're reefed. And when they look at these 2 changes, they're structural changes to a couple components that aren't, I would say, integral for exactly how that parachute inflates. We have had the NESC, NASA Engineering Safety Center, as part of the assessments of parachutes. We also are very fortunate to have a few individuals that have actual parachute heritage all the way back to Apollo, and they've advised us that these changes are in that realm where maybe only one drop test should be required. And if we learn something on that test, we'll get another parachute and design another drop test, and we'll go do a second test. So, and I'll see if Mark has anything to add.
You characterized it very well, and I think it's also important to point out that we have some of the best experts on parachutes between NASA, Boeing, and Airborne. And you highlighted a couple of others that came in as independent overseers of the decision as well. So I don't think it should be taken lightly that our experts unanimously agreed that this is the appropriate approach to guarantee that we have good chutes. We'll also do the same inside of Boeing as the test matures to make sure that our engineering community all the way up through our different general managers, staffs understand the test and support it as well.
Thank you both. The next question comes from David Curley with the Discovery Channel.
Thanks very much. Still on parachutes, and my apologies. My phone dropped off just when you Stitch were talking about it, and didn't get back until Mark had kind of gone through some of it. But you mentioned that looking at the parachutes, you studied the entire system. You didn't say whether or not additional problems were found in other parts of the canopy during that study. And moving to the next generation and requiring the test, was that because problems were found, or just the timing issue that the next generation is going to be available now with the delays? Thank you.
Yeah, I could talk about the review that was done, and perhaps Mark can address this next generation, what we call the -511s. I would say when we did the review and we looked at all what it's called is seam and joint testing. In other words, there's a sewn joint on the canopy or on the structural grid of the parachute, and then what has to take place is that you do a certain number of pull tests, and you assess the capability of that joint given the forces that it will see in flight as the deployment happens, and then as it hangs finally, as the capsule hangs under the parachutes. And when we did that review, we found a couple areas where perhaps there was needed to be a couple more tests done to complete. Typically, sometimes there's 5 tests required, sometimes 10, and so there was a couple areas where we wanted to go do a few more tests. But when we looked at the margins in those areas, we didn't have any concern. So it was good that we did the thorough review. We also did a review of all the drawings of the parachutes, and then how those drawings are turning into what I would almost call a work instruction, so that there's a technician then that can go, sew that particular part of the canopy together or put that joint together, and we didn't see anything unusual with any of that. We also brought in an expert on what's called the seam and joint testing from the NESC, and he went through all the data and all the margins are acceptable for flight. And I'll let Mark talk about the decision on the Dash 511s.
Thanks, Steve. So the Dash 511s, we were faced with two really good decisions. Both decisions would have been perfectly fine to make, whether we were to take the 509s, which came off of CFT, and apply the soft link to those and fly those, or go straight to the 511s. And so, you can't really make a mistake when you have two good decisions in front of you. But the decision to go to the 511s was really that, they both had a little bit of pros and cons. The 511s took a little longer, and the 509s they had to be repacked again, which takes a little bit of strength away from them. So we said, let's just we're going to go to the 511s anyways. Let's go to the 511s and do the testing that's required. Piggybacking on the last question, as Steve has said, the configuration changes to these different configuration chutes is very, very minor. And going from the 509s to the 511s, besides the soft link being added, there's just a row of stitching that is being added to where the riser comes up into the canopy. So it's a relatively small change. And, this test is very sufficient to test that change and make sure that it is sufficient for flight. So we made the decision to go to the 511s and do the drop test. And again, it was a little bit of a penalty on the time that it took to get the chutes, but it's worth it.
Thank you. Our next question is from Micah Maidenberg with the Wall Street Journal.
Thank you. Mark, just how confident are you that Boeing can achieve just readiness in March, given that various previous dates for Starliner, haven't been met? And are you, fairly confident at this point there won't be any further new issues that emerge? Thanks.
So I can talk to the past, and we always learn from the past. And, we had set some previous dates, but we had work in front of us that was a lot of first-time projects or first-time products that had to be approved. And we made our best guess at the forecast that what it would take to get those products approved, and it took longer than we had planned. Again, we do it right, so it takes the time that it's going to take in order to get through the process. This time, the work that we have in front of us is rather straightforward. We have the parachutes that we have being built at the supplier, and we're working with the supplier to ensure the delivery. We have the tape work that's being done that will be done well in advance of the need. And then we also have the parachute drop test that, again, has quite a bit of margin for it to be performed, the analysis to be done, and then us to be ready for flight. So, the critical path goes through the readiness of the parachutes. We're working closely with the supplier to assure our readiness. We put some margin in that. And, there's always the mystery of, something else that can pop up as we finish the build of the vehicle and get it ready to be stacked at the launch pad. And we can all just, imagine what might happen, but it's not what we work to. We work to plans, we work to forecasts, we work to what we know we have to do, and we have a pretty good schedule laid out to get there.
And the last question we'll have today is from Joey Roulette with Reuters.
Thanks. Quick one for Steve. Is Starliner's battery system considered a safety critical item? And if so, does it satisfy that safety factor of 2.0 for CFT that you mentioned earlier on the call? And Joel, is the investigation into that Malka anomaly in 2021 complete between NASA and Roscosmos? Thanks.
Yeah, I'll take the battery question first, and then there's a little difference, I would say, in the batteries versus the soft link. The soft link really is a factor of safety at 2.0, means that essentially you could pull on that joint with twice the force that you'll ever see in flight, and it would handle that kind of load. So it's got that kind of margin baked into it. The batteries, there really isn't a safety factor per se for the batteries. I would say we continue to look at the battery system overall. You know, we've got a redesign plan, and we've been working on that hand in hand with Boeing. We have done some additional testing on the cells, and we are now understanding how the cells perform at lower states of charge, which gives us a little more confidence on the battery system even for crewed flight test. And then we'll do another test likely here in September to test the whole integrated battery system, and we'll have that done before crewed flight test. Right now, everybody has approved the batteries for the crewed flight test, and we have some mitigations in place for the Starliner 1 flight, which will go work through the board process. And then, as I've said, long term, we've got a battery redesign planned, and that's really to make them what's called passively propagation resistant should that cell overheat, which we've never seen with these particular cells. I think I talked before that we do a lot of extra screening on the cells for these batteries as compared to the cells that you might have in your laptop or other vehicle. They go through an extensive screening process. We look for FOD in cells. We take some of the cells apart. We keep them in a freezer. There's all kinds of things we do to protect the cells and batteries for flight. And I'll let Joe answer the very last question.
Okay. On the NIUCA, or often called the Multipurpose Laboratory Module, or MLM, that work is closed. It's transitioned to more of a documenting the lessons learned with the anomaly and how we can pass that along to other programs at NASA and other programs that we do with our international partners and domestic partners.
All right, everyone, that's the time we have for today and all of our questions. Thank you very much for joining us for this update on the Boeing Starliner spacecraft and our future plans through the Commercial Crew Program. You can learn the latest information at blogs.nasa.gov/commercialcrew, and we'll talk to you again soon.